Hey class, it's Dr. Homepage again. Sorry, that's a picture of my daughter when she was a baby. I have it on my desktop. Bear with me just a sec. I'll open to a Word document here. So today we're going to talk a little bit about hypotheses. In your milestone assignment this week, they're asking you to name null and alternative hypotheses for your chosen data scenario. This is just something that historically has been a little bit difficult. As we move into this part of the course, a lot of the statistics gets a little bit more abstract. So it's just helpful, in addition to reading the book, in addition to going over the resources provided you in the course, I'm going to try to make your life a little bit easier by giving a scenario and maybe talking about how I would think about null and alternative hypothesis. So first we'll talk about the scenario, and then we'll kind of talk about what null and alternative mean, because they both really represent like theoretical distributions in a given scenario. I know that's not super helpful to say it that way, but let's just do the example, and I think we'll see what I'm driving at there. So in this scenario, we're looking at a t-test. So this is what you would want to be thinking about if you were choosing to do, or your data set requires rather, that you do a t-test. This is going to be a two-sample t-test. It's not going to be a paired sample t-test. So maybe I'll correct that here. So two-sample t-test scenario. A real simple one. We're going to imagine that I actually garden and that I have two tomato patches, and I'm curious to see if a new organic plant food is going to increase the size of my tomato plants. So in tomato patch number 1, I have treated all the plants with the new plant food. In tomato patch number 2, I've not treated the plants with the plant food at all. So I'm going to do the same thing I usually do. Outside of that variable of having plant food, both patches are in the same spot in the yard. They get the same amount of rain, sunlight, and maintenance. I've made sure that I've separated them enough so that one gets all the plant food and the other does not. But outside of that plant food variable, things are pretty much controlled. And then I'm going to let them grow for several weeks, and I'm going to keep using the plant food. But then when it's time to harvest, I took measurements of all the tomatoes in each patch at harvest time. Okay, so I'm not even going to start talking about data and what the data look like. Because at this point, I just want you to be thinking about what this scenario means. Okay, in a t-test, what we're really looking for is a difference between two means. Is the mean of the one group different than the mean of the other group? And if so, which mean do we expect to be bigger? That's all we're trying to figure out. Is one of the means significantly different than the other one? Is the difference enough? Here, I'm expecting the plant food will work. I'm expecting that if this works, the mean tomato size in patch 1 is going to be more than the mean tomato size in patch 2. So that's going to be my alternative hypothesis, or my change hypothesis. That if there's change, or there's significant difference, or there's my hypothesis results in a significant difference. There's a lot of different ways they term this in stats. We denote it with HA, the alternative hypothesis, and we're going to say that in this scenario, the mean of patch 1, where I had the plant food, is going to be greater than the mean for patch 2. I just use an M. I don't really get into the Greek letters when I'm typing in Word. I don't expect you to in the class. Actually, a great way to answer these in class is you can just write it out. Like, it's totally okay for you just to say this as an answer, even if you don't have the notation. I'm not really a stickler for notation. I just want you to know what it means. So that's if this works. Now, supposing the plant food doesn't work, there might be a couple scenarios that play out. Let's just say the plant food is just bogus and it actually shrinks the size of the tomatoes. That's a possibility. Or it could just have no effect at all, where the mean's really not significant enough to say that, yeah, this plant food works so well that there's a significant change in these tomatoes. So my null hypothesis, or no change hypothesis, would be that the mean of group 1, or patch 1, is actually less than or equal to the mean size of patch 2. And again, you don't even have to worry about typing out less than or equal to, or whatever keystrokes that is. I don't, because for the purposes of this course, it may actually just be better to write it out if you want. That's totally fine. You can do it however way you want to do it. I'm mostly concerned with what you're saying, though. So in this case, it's important to point out, though, that I'm expecting the change to be in a certain direction. I'm expecting this plant food is going to work, and that it's going to change the size of my tomatoes for the bigger. So in the wild event that it actually makes the tomatoes smaller, I'm actually building that into my null or no change hypothesis. So this is a directional hypothesis. I'm expecting the change in a certain direction, which is that patch 1 is going to be greater than patch 2. Going forward, and I just want to see what time I'm at here. Okay, I'm at 7 minutes. Going forward, we could have a different hypothesis. I'm going to show you an example of a non-directional hypothesis. So it could be that as a researcher, I don't really have a direction that I'm predicting this thing's going to have an effect. Maybe I just hate all plant food. I think all plant food's bogus. I'm not really expecting it to work at all. And so I could even do a simpler non-directional hypothesis. I could simply say that if this plant food doesn't work, I would expect the means to be equal. And then if it works, if I have a change hypothesis, then I could say my alternative hypothesis is that simply the mean of patch 1 is not going to be equal to the mean of patch 2. So again, my null hypothesis and a non-directional hypothesis is very simple. It's just that one mean is not going to be any different than the other one. This stuff isn't going to have any effect at all. And again, my alternative would be the mean is not equal to the other mean. There's some effect, and these two means are of different size. There's a significant difference between these means. And again, you could even label it as such and write it out. That's a fine way to do this. What determines whether you're going to use a directional null and alternative hypothesis or a non-directional? It really depends how your research vignette is written. It really depends on what you think is going to happen as a researcher. Both of these give you some data. Both of these can be useful, but one of the things that is kind of important when we start to think about the actual statistics part of it, when we start to think about bringing in the numbers, is that this ends up being a one-tailed test when we do our t-test, which is a little bit more stringent. This ends up being a two-tailed test, which is a little less stringent. So because we're expecting this to go in a certain direction, basically we're going to be a little bit more precise with our t-test, and we're going to be a little bit more exacting. Here, we're going to leave it a little bit more open to interpretation. And so there would be a slight variation in how you do the tests. But for now, though, because we're just in week 5 here, and we're going to build this gradually, I just want you to be thinking about what direction does this, research vignette indicate? Or maybe does my research vignette that I've selected for this course in this final project, is it indicating no direction? They don't really know which way this thing's going to happen. So that's going to be the part that I'm going to leave you to wrestle with a little bit conceptually. And you can certainly email me with questions you have on that. But, these are just some ways that you can notate. You can feel free to write it out. You can use my kind of weird shorthand. If you want to be, if you're really great with Word documents and you want to put the mu, the Greek letter, that's fine too. But mostly I'm just concerned that you're expressing fully what you mean and writing, as accurate as you can an alternative and null hypothesis. I'm going to take a quick look, since we have a couple minutes, I have this whiteboard drawn out. It looks like Homer Simpson did it, I know. But I want you just to think about conceptually what a null and alternative hypothesis mean in statistics. And this is sort of the way I think about it, is that theoretically there's two distributions of data that go with our null and alternative hypothesis. So when I say theoretical distributions, I just mean, if I measured tomatoes, if I spent my whole life measuring tomatoes, I'd have all this data about the size of tomatoes. But here, all I really know is that I've got this plant food, and I can kind of imagine that there's a situation where, there's no effect, and that all my scores, or widths rather, for plant size just kind of fall under this distribution where nothing really changed. And then I can imagine that if this plant food actually works, there's a separate theoretical distribution that would represent a bunch of widths or sizes of tomatoes that would reflect if this plant food was really something and had an effect. And when we get into hypothesis testing, the most simple way to think about it is really that there's this theoretical distribution associated with no effect, and there's another theoretical distribution associated with another effect. And that's kind of what we're, working with. We don't, again, in stats, we don't have all the data on the population, so we just kind of have to assume that, if there was an effect, we'd be able to notice a difference in the mean score in our samples. I'm not really going to go any further than my poor Homer Simpson diagram, but I just want to get you thinking about hypothesis testing a little bit if you're doing a t-test for your example. And just know that all we're really talking about is that there's a theoretical distribution associated with the null hypothesis, and there's a theoretical distribution associated with change. And that's kind of it. And you can maybe think about this in real life. If you had a bunch of tomatoes and you were putting smaller ones in one bin and bigger ones in another bin, the smaller bin would have like a smaller mean and smaller tomatoes around that mean. And the bigger bin would have probably a bigger mean size tomato and bigger tomatoes around it. And that's kind of what it would look like in this scenario. So again, I'm trying to make the theoretical maybe a little bit real for you, but just keep this picture in your mind if you're doing a t-test, because it's an important thing to just have conceptually, and I'll end it at that. But that's how I want you to think about null and alternative.